All right, everyone, welcome to Red versus Blue, a live attacker-defender showdown of Kubernetes security. So I'm Lucy. I work in platform engineering at Uber, and within the Kubernetes project, I'm on the Node Lifecycle Working Group, where I'm one of the leads of the working group. And I'm joined on stage today by Sandeep.
Thank you, Lucy. Everyone, I'm Sandeep, and I'm a engineer. Doing the slide, if you see it, is something like a needle in a haystack engineer. And so what needle in a haystack basically means is that when something breaks in production, I'm often being called to find out what is the root cause. So at times I'm a developer, at times I'm an SRE, at times I'm an observability engineer trying to find the needle in the haystack. And I'm also the co-chair of the dev and the hard of hearing working group. I'm hearing impairment, and I rely entirely on captioning. So if you see the mobile in my hand, I'm not checking emails. I'm just trying to follow what my co-speaker is speaking. Thank you.
I don't know if I believe that, though. But yeah, so so a few disclaimers before we do this. This is an actual live demo. Don't worry, we've robustly tested this. We've tested it one time in full. That was 2 hours ago. So hopefully the demo gods grace us. If they don't, then live debugging may happen on stage. Extra content for free. Amazing. We've pre-prepared some files and commands because otherwise we would be here for hours. The amount of times I've messed up basic kubectl commands is almost embarrassing. So instead, I'm just going to paste them. And this is not in any way, once you've done this, your cluster is secure forever. You have perfect Kubernetes security. If anyone from SIG Security is in the room, they would kill me for saying that. This is much more of a sample of the ways that things can go wrong. So with that, should we come over to the terminal, which we have here? Sandeep, do you want to go through what we have on the terminal here?
Sure. So everyone, I think first of all, UC was wrong. The last test was not done 2 hours back. The last test was done only 7 minutes back, just before this. So for information, we have a local CAN cluster. Everything is 100% offline, and basically I think I could just switch off the Wi-Fi here to be safe, because anyway the Wi-Fi is not working, right? So I had a lot of fun preparing this offline demo, and the aim of this is to educate you. So we are going to have some simulations, and I'm going to be the attacker. I'm going to basically be the bad guy, and she's basically going to be the good girl. So it's an attacker versus defender. And as an attacker, you will see me in the red terminal, and as a defender, you will see her in the blue terminal. So the first thing that I want to know is, before you suggest, I think, are you all able to read it clearly? Good? Yeah. So what I have done is simply I started a netcat that is listening on port 4444. When this happens, and what really happens because of that, you will basically see in a few minutes when Lucy deploys her pod. Okay, Lucy, time to get into action.
All right. Okay, so I have a Kubernetes cluster here that I'm just deploying my applications on, and I'm going to deploy a new application today. So I've got a little TiDB database over in my terminal, which is this one, and I'm going to make it bigger. Tell me when it's big enough. Big enough? Awesome, great. So I've got this little database that I'm going to deploy. It's got a deployment, just some cluster roles, and a namespace and everything. Pretty regular sort of YAML. I've just scanned over it, so I'm just going to apply it, because what could possibly go wrong applying random YAML from the internet? So I've done that now, and my pods are up and running. And I can move on with my life, right? I'm all done, and this is a very secure deployment, and nothing is possibly going to go wrong, right? Sandeep?
Okay, it seems to me that Lucy was basically partying the whole night, I think. What she has done, she does not even know. Okay, I'm just hoping the demo works now. Oh, you see, I was listening on 4444, and now I have basically got a cell access. I did not do anything. I was even staying behind. That is why I was saying that Lucy was partying all the night. And what Lucy has done here is, let us see something. Okay, Can any of you figure out what has happened here?
TyBD or TyDB? Which is the correct name of the TyDB image?
Instead of deploying the TIDB, she deployed my malicious image. That malicious image gave me a reverse shell entry. So now let us see what Pavas has accidentally got here. Okay. Oh, I'm root here. Okay, that's fine. But I mean, she has deployed a database, and basically every database has a root user access. So, okay, I'm not too much happy about this. Okay, let me see what else I got accidentally. Okay, let me see. Let me try to listen. Okay. So I still cannot see the Kubernetes directory here. No, that is not fair. I have a way. What I am doing is basically, let me see. You see all the FF? All the FFF means is that I basically have superpowers of the Linux system, something much more than root. So you see only deploy the pod. And what am I going to do is, from the pod, I'm going to move to the host system itself. So this is basically a command that I'm running on the host system itself, and I'm able to see this. So now that I'm able to see this, let me see if we can see the kubelet config directory itself. Okay. So now I have access to the kubelet config directory, I have access to the certificate, credentials, and everything. I can basically impersonate. I'm sort of the superpower. Uses cluster is almost my cluster. And let's spawn UC. So now, okay, I think this should be a no-brainer. I could read the passwords here, that's all. So what we are going to do is, we are just going to see if we can actually write to the host file system itself. Okay? And let me verify if we have actually written the file or not. It's a game over for one. So in the chess match we have 4 rounds today. The round 1 is over. You see up to you to defend now.
All right, I don't know about this. I asked ChatGPT and it said that I could get around all of my permissions issues by just giving privilege root on my pod. But let's see, did you actually get into my cluster? Let me see. Oh, this is just still running, nice, okay. Okay, maybe you did. So what the heck has happened here? I hear from, right? Yes, what the heck has happened here? Well, Kubernetes gives us the ability to create containers with some level of capabilities. And some of these are very powerful, capsysAdmin being the most powerful of all. If you have capsysAdmin, you basically own the host. You own wherever the kubelet is running. And so with that, you can do all sorts of fun things. You can you can mess with the secrets of other workloads on there. You can mess with the kubelet itself. It's not the greatest. So let's see if I can get Sandeep off of my cluster. So if I look on here, I can see that my namespace here has no restrictions on pod privileges. So as a engineer using my cluster, you can create a pod with root privileges, with whatever the hell you want. But there are features in Kubernetes that we can use to stop this. So right now, I am actually giving it the security context privilege true. Oh, hello. Am I not holding this microphone correctly? Oh, okay. I'm getting thumbs up. Thank you. I'm giving it allow privilege escalation true and privilege true. But now, I'm going to add these labels to the namespace. And what these do is they enforce something called pod security, which means that from now on, you can't make pods with root privileges and things like this, right? So I've done it immediately. I'm getting warned. I may have broken that rule with my amazing secure deployment from before. But now, if I try and create a new privilege pod, this one also is meant to have root, I'm just not going to be allowed to do that. Forbidden, error when creating pods, it's not allowed. And so if I'm another person on my platform engineering team, I also can't now create even more pods with root level privileges. Okay, so I've done that. So this cluster is now 100% secure, right? That's it.
Nice. So basically, you see applied the pod security standards. And so now, my shell access is almost gone, but UC hasn't redeployed the pod. And that is intentional because just for the purpose of this demo, I don't want to lose my cell access just to make the demo simple. But the post security standard is now applied. So I think, okay, what next we can do? Okay, let us see if UC actually applied the RBAC policies or not. Let us see that. So since I still have the cell access, or if I don't have the reverse cell, I could just do kubectl exec. That's it. So let me actually see here. Okay, so every pod by default automatically it gets the service account, correct? Because that is how the pod talks to the Kubernetes API. So now what am I going to say is that, what am I going to say is that we see a token here, and let us see what powers our token has. So I am just going to grab the token here. Okay, fine. And then I'll just get the namespace so that I can actually fire the API. Okay, we are going here, and then let's see the token length. Oh, so the token length is more than 1,000 SAR. Okay, so basically there is something, and what power the token has, let us see that. So the token can talk to the API. The token is a valid token. Okay, you're still not out of a hangover. Okay, so the next thing is that I'm going to see if I can list the pods. Okay, I can list the pods across all the namespaces. Okay, now I want to go further. Can I get the secrets or not? Can I get the secrets of the kube system or not? So here is the third one. I'm trying to read the secret of the kube system namespace. Game over. I have basically an access, my token is valid. So what am I going to do is, we are going to create a malicious pod. Let's see that. Okay, we are going to see, okay, now how do I know if the pod is really created or not here? No, you see, game over.
Oh, God damn it. Here we go again. So what did Sandeep just do this time? So Kubernetes has this concept of service accounts, which are meant for robot users and things to interact with your cluster. They're just like users. They have roles, permissions, just like everyone else. And one of the features that Kubernetes gives you is it can automatically, and that's not a typo, I meant that, bind a service account to a pod. So this pod then can take on that service account's identity and can act as it within the cluster. And I may have made a bit of a permissive service account, but one of the interesting things about this is, in general in Kubernetes, if you can create pods, you basically own the cluster. Because say I have a setup here where I have my pod, my database one, and it's connected to some pod manager service account. If there is a cluster admin service account or anything lying around, all Sandeep has to do is make a new pod bound to, where are we? I don't know which one you guys are seeing. You're seeing that one. I should look to my right often. So yeah, all Sandeep has to do is create a new pod using the permission to create pods and just bind it to that cluster admin service account. And he can basically do from there whatever he wants. So it's one of these things. Some permissions are much more useful than others, even if they don't necessarily look at it first. Like the ability to create pods pretty much means you own the cluster, at least in K8. So let's see if I can get rid of him. So first off, if we have a look at the permissions I gave that database service account, I might have given it quite a few. Maybe that was a mistake, but I just didn't want to deal with it anymore. So what I'm going to do now is I want to copy this file. I want to cat this. So I'm going to... Oh, I should probably paste this properly. Cat... Not my MacBook. Don't judge me too much. Oh. Okay. Like that. Hey! How many engineers does it take to run one cat command? That's what we found out. So this one is a lot more tight. Only allows reading some basic config maps and some self-introspection. So I am going to apply that to the cluster instead. Let me do that. And I'm going to delete out the older database admin ones, the ones that were maybe a bit too open. And I'm going to delete out that backdoor pod that Sandeep made, so we can't keep that around. And now if I, too far. And now if I look at what the database pod can do, it can't do any of those things that it could do before. So, surely now this cluster is 100% secure and there's nothing else can happen. Foreshadowing is a literary device.
Thank you, Lucy. The one thing that I would really like to call out is that Lucy is basically holding the mic in one hand and trying to use the command using just one hand. So I really appreciate that. So now the privileged pod abuse is thwarted. The RBAC is thwarted. So what options do we have left now? Okay, what options do we have left? Let me see. Lucy did not apply any limits or quota. So what if I were to start a crypto miner? What if I were to start a fork bomb that basically loops? Now, if I basically start a fork bomb here or a crypto miner here, the current cluster will die and we will all have to leave from the middle of session. So, for the purposes of demo, I'll just create a loop of just like a loop that only loops from 1 to 4. Okay? Okay, so now we are no longer in the reversal. We'll get out of the reversal. Yeah. Okay, now this is a normal. Here I am going to do a kubectl exec and then I'm going to get access to the cell here. Okay, now let me start just a simple for loop. That's it. Okay, so in the real-time system, basically I could use an infinite for loop. Okay, it could be a crypto miner, fork bomb or something, a process that spawns and spawns and spawns and continues spawning new process. What will happen is that the system will run out of resources. So basically in this case, Lucy hasn't given me any special privileges. She hasn't given me any special privileges, but she hasn't applied any limits or something, and so I could exploit that.
Oh well, here we go. Some of you in the audience may have noticed that this wouldn't actually run a cluster out of resources by itself. But remember, the cluster is on the laptop, so if you want me to make a point, I have to crash the entire laptop and demo. So slightly contrived, but we'll go for it. So what the heck is Sandeep doing here? So in Kubernetes, one of the annoyances that you don't just see from dishonest users, but even honest ones, is without resource quotas, you truly can use as much resources as you want, even if that means that you have one customer who decides to use 99% of an entire cluster's resources. This happens all over the place, and honestly, the majority of the time, it's not even malicious. It's just someone going, oh, free compute, I'll take that. That then leads to all the other customers on the cluster trying to spin up pods, whatever. They can't do so. All the resources are gone. Sandeep here has now used this maliciously or pervasive. I've forgotten how English works, but he's in his example, he's using it all so that nothing else can run on my cluster. So how can I stop him? Well, if I look in here, in my, I'm in this terminal, you can see I have no resource quota and no limit ranges anywhere in my namespace. So that means by default, this database tier namespace can just take the entire cluster. That is completely fine. So first off, let's get rid of this pod here that is just eating CPU clock cycles for fun. And then let's have a look at a resource quota that we could use instead, which if I see I've learned how to use cat. I've done that on stage. I've learned something new every day. So this resource quota here restricts down what these database tier can use. So it can only use now a much more reasonable amount of CPUs and memory and so on. And if I have a look at this limit range as well, let's cap that. This again restricts how much each individual pod can use. So if we now apply, and limit ranges for context here, they allow you to set they allow you to set limits on the ranges in which values can be within objects. Okay, so if we apply that, now we have these resource quotas and limit ranges, which I think you all saw me apply it. Let's see what happens if I try and apply this resource hogging pod to the cluster. So it gets created, but then if I look in the describe for it, you see now it has limits applied to its usage. Cool. Let me just delete this now. Okay, so now I have no root privileges on my containers. I have restricted service accounts. I have resource quotas across the namespace that Sandeep has control in. There is no way that he can get around this at all, right?
Thank you, Lucy. I very much like one point that Lucy made in this, is that basically even honest users can basically accidentally abuse the resource quota. Like if you are an admin of any project like AWS or GCP, have you ever gotten emails like your resource quota, your budget exceeded 100%, 200%? I often get emails that 100% of budget exceeded, 200% budget exceeded, because you see if you go to the solution showcase, they will all tell you everything is simple, just click one button. Obviously you click one button, but internally it starts consuming dollars and resources. And then, so basically, this is a very, this exercise is a very good concept of security where even honest users can accidentally end up doing this. If you are not aware of what the resource limits are there, not only your resources but even your cost and budget exceeds. So with that, we come to the last attack here. So now my pod privilege, my hands are chopped, RBAC is chopped. Okay, a resource quota is exhausted. What do I have remaining now? Do I still have something? I think there's still one more thing remaining, is that basically I could use a lateral movement if I have an access to a pod, and if Lucia started something but not actually secured it, from one pod I can get access to a production cluster.
This is nonsense. I secure all of my deployments.
You have to deploy your production cluster now.
Yes, speaking of which, so now that I know there's no way Sandeep can jump on this cluster, I'm going to throw a few more workloads of mine on here. So if I show you this file, if I can make the trackpad work, not car, we have a lot of those in America. So I'm going to set up an admin dashboard, whatever, I'm just going to apply that into the cluster in a different namespace. Cool. This cluster's secure, so this is not going to be an issue. No.
Okay, so basically Lucius created a production cluster, and actually let us see. So you see here, there is a database running. Okay, let us actually see one database, and then we have an admin dashboard running. Okay, now let us see actually, let me go back to my REST shell. Okay. Okay, so Lucian deleted my pod in the previous step. Okay, so I have to basically reapply the pod, and now I'm reapplying without any privileges. Okay, because my privileges were chopped off in the first attempt. Okay, so now that this is done, let me see what. Okay, fine. Now let me get a reverse shell. Sorry, not a reverse shell, just a normal shell again. Now let's see that. So Lucian deployed a database service, okay? It is a PostgreSQL, and I'm basically able to connect to the phone directly. There is nothing applied. That's all. Okay, now let's see on the admin dashboard. Let's see. Beautiful. I have access to the admin dashboard. I have access to the PostgreSQL. Okay. And I think I'm just going to do this NS lookup, although I think having a DNS, okay, DNS doesn't give me too much. But the thing is that this demonstrates a lateral attack. Using a pod, you can basically gain entry. So you see this is the last line of defense.
All right, fine. So what the heck has Sandeep done this time? So if I come in here, yes, this is what you see. So he has decided that once he's in one pod, he's going to move across my cluster to all of my fun internal services. I have a nice admin dashboard running in a different namespace from my database. What he did is he found out that it was running there. He asked about kubedns, where is it? And it said, hey, here's an internal cluster IP. And he just went and dialed it. And my admin dashboard has the service is not exposed to the internet. There's one in front of it that authenticates everyone. So the idea is once you hit this admin dashboard, I just assume that you're okay. So because he's hitting a request here, I assume it's fine. I'm like, sure, I'll make that account admin. What could go wrong? So let's see if I can solve for this. Well, if I have a look at my network policies on my cluster, I have absolutely nothing. So first thing I'm going to do is apply this one. Can I cap this one? Yeah. So this just makes it so that by default the rule on networking is you can't do it unless you have a reason otherwise. And then this one here adds some much more sensible policies on what networking is allowed to happen. So, for example, you can do DNS, you can access the production database, but only if you're from specific places, aka not the database doing random outreach to the customer production system for some reason. So I'm going to apply that. Nice. And now if I look at these networking policies. Cool. So now the database namespace can't just reach out to any other namespace in the cluster and just start messing with it in ways that I never intended. Okay. So I think with that you can't do any more network movement, can you, Sandeep?
Okay. So this brings us to the end of this talk. I think okay. Let's see that. I think I still some time. Yeah. Let me see that. So it uses cluster secure. Yeah. The time I could not connect to the database. Okay. Now let me connect to the admin dashboard. Okay. That also doesn't seem to work here. Okay. So I think that's a good job, you see. I think the DNS will still work because you see explicitly allowed the DNS. So that brings us an end to this talk. We hope you enjoyed this demo and found it useful.
Yep. Thank you. That's the. Sorry, I got it. I'll go right. Perfect. Thank you. Yep. So that's the end of our demos of some of the ways that you can get owned in Kubernetes. It really was. That is the second time I have ever run through that. So apparently, demo gods went well for us. But with that, I think Sandeep, you want to talk briefly about merge forward, and then we'll go to questions. Yeah.
Yeah. Thank you, Lucy. So merge forward is an initiative where we have all of the underrepresented groups, like the deaf and the hard of hearing working group, the blind and the visually impaired working group, people of color, LGBTQ, like Friends of Dorothy, neurodiversity, all the 7 subgroups, and they have all been bracketed under the Merge Forward initiative, which is a new one. If you can scan the QR code and join the Slack channel. And the reason I'm saying this is because as minorities, we can only do so much. Without the support of elites, we cannot really amplify our advocacy efforts. So please do join the channel, please show us some love, and please advocate for us. Thank you so much.
All right. Thank you. All right. We have a microphone in the center if anyone has any questions. And if anyone from Securi is here, please don't judge me too much.
I think ask them to give us feedback on the QR.
Oh, yes. And please give feedback on the QR. If no one has questions, that means I did an amazing job on my presentation. That means that I literally covered everything. We are so good at this. Yes. But not everything.
All right, I got a question. Thank you for the talk. I think this was fantastic. It's really awesome to see both from the red team and blue team perspective, both things. From a red teamer's perspective, if you have a cluster that doesn't have a lot of good network policies, what would be some of the things that you would want to do to kind of enumerate some of the like priority DNS entries that you would want to hit?
So kubedns publishes out, kubedns publishes out the services through kubedns that you can then see. In terms of enumeration, just to clarify here, are you looking for like, like you want to find like services you probably want to hit, that sort of thing?
Yeah, so like something that would be interesting for a red teamer to hit. So like, I don't know anything about a cluster. I'm going in like completely cold. What would be some of the things that I would use to enumerate? Like this might be an admin dashboard I want to see if I don't know any.
I mean, normally, yeah, I use kubedns, and then I would also do service account introspection if I can. Outside of that, you can sometimes send it on the same kubelet host. But yeah, that's it. One of the annoying things about reconning with DNS is you kind of have to know what you're looking for already, and that can be a challenge. Although I will say, if there's no rate limit on the DNS and that you have a nice list of what's it called, a rainbow total? I can't remember. But I have like a huge list of potential ones, and I just have all of them checked. And then if I get any results from that, that's what I do. I think I have the list somewhere. I'll send it to you after if you want. Cool.
Yeah, thank you. Yeah.
Awesome. See, now one person's done it. Now everyone will do it. Great.
Yeah, absolutely right. So could GitOps principles and strong continuous delivery kind of mitigate some of those attacks already? I mean, you'd be able to create the pod, but then my GitOps and continuous delivery platform should shut it back down almost immediately, right?
It's tough. GitOps could be a nice place to do like enforcement of not doing this. I'd say I'm a bit hesitant about GitOps being used to like actually stop an attack in progress, just because if I can get this pod running, then I'm still going to have a window to mess with you, right? Before I get kicked off. And you know, it took us a while because we're humans, but if in reality, most of these attacks are not like a human in a reverse shell. It's a program that already has its objectives out there and will get them done within a few seconds, right? But definitely, you can definitely use GitOps at least to some level to enforce like, please don't put PR in a pod with like root level privileges and cluster admin service account and so on. But I wouldn't say it's like part of the actual response, at least to me.
Will you throw those commands, files, etc., somewhere for us to grab post-conference?
Yes, we're going to throw them on a GitHub. Sandeep, do you have the GitHub link? Okay, cool. If you want, I can let you know, but I'll also put it on the material on the schedule as well, so that it's on there as well.
Awesome, thank you.
Yeah, we'll be uploading this entire on the GitHub, so you can just download and run it.
Should we do one more, and then let's call it? Congrats, you got the last question.
Thank you. So you had a lot of good stuff on there about like network policies and PSA, like pod security admission restrictions and stuff. Are there any other tools that exist that can help you prevent the creation of something like a bad pod from the get-go beyond PSA?
Yeah, you could use Admission Webhooks, for example. A lot of companies are using those to say, like, I want to run some business logic on this pod before it gets created. That is very, very common across K8s. The only downside to it is Admission Webhooks are not very observable in what they do. It's just like, here's a HTTP endpoint, and magically you get a yes/no answer from it. It's not something that you can really introspect and see in K8s. So if you can express things through the normal core APIs, please do. But yes, a lot of people will then, once you get beyond that, go for an admission webhook, have a server there.
And maybe something like a validating admission policy?
Yes, exactly. That sort of thing. All right, cool. We'll call it there. Thank you so much.
Thank you. Thank you.